Hi, I'm Miss Lorson, and this is day 2 of making a science demonstration video every day that my school is closed for the novel coronavirus COVID-19. Today I'm going to be talking about fluids and how they act, but the reason that I'm talking about it is not because we're learning about water, but because we're learning about air. My 8th grade is studying weather and atmosphere, and it's actually really hard to show what air does without some better equipment than I have here at home. But I can show you how water behaves. And since air and water both behave like fluids, because they both are fluids, I can give you some of the same information using just some water and food coloring. So I'm going to switch to a different camera to give you a better view of my water and food coloring, and then we'll finish. Okay, so I have 2 containers here that are the same size, the same material. The only difference is that this one has cold water in it, and this one has hot water in it. It's even water from the same place. It's just water from my tap. And I have 2 bottles of food coloring. One of them is teal, and one of them is magenta, which is just fancy for blue and pink. And I'm going to put 2 drops of the blue food coloring into the cold water and 2 drops of the pink food coloring into the hot water. And if you've ever taken any kind of chemistry, even just middle school chemistry, I'd like you to predict, before I put it in, what you think is going to happen with the food coloring. Remember, the only difference between the 2 containers is one of them is hot and the other one is cold. Make sure I have my food coloring in the correct hands. Right away, the first thing you might have noticed is that the food coloring dropped to the bottom of the containers very quickly. This is a gel food coloring. It's a gel food coloring, which means that it is denser than pure water. So it is heavier than water, which means it just dropped right to the bottom. The other thing you might have noticed very quickly is that in the hot water, the food coloring is starting to spread out. You can see all of the water now looks a little bit pink. We do have more food coloring at the bottom than at the top, but it is all pink all the way through. Whereas in the cold water, that blue just dropped to the bottom and it's mostly staying there. We have a little bit of it in the water, but it's not moving very much. And the only way that we can see these molecules are moving is because we have something in it. And in this case, it's food coloring. You could do this with, I don't know, biodegradable glitter. Don't use real glitter. Real glitter is terrible. But anything that you could see moving in the water, you could try this if you have packets of Kool-Aid or another colored drink mix at home. You could try that and see what happens. And there are 2 things that you might notice if your drink mix has sugar. And one is that the color spreads out faster. The other in hot water. The other is that if you use warm water or hot water, it's easier to get the sugar to dissolve. And those are both the same thing. It's the same reason. And that is when you heat something up, the molecules start to get a little bit faster, which is the thing that you should have predicted if you were paying attention in my 6th grade class, if you had me for 6th grade. Or 7th grade or 8th grade, because we talk about it all 3 years. The molecules speed up when they heat up. So if you add energy into the system, then you're making the molecules move faster. So it's like a dance party. When you turn on better music, you get faster dancing. So these molecules are moving faster and faster, and it's like it's stirring the water that's in this jug. Whereas this jug, the food coloring is spreading out a little bit more now, but it is really just barely moving. We have lots of this water that is still just clear water. It does not have any coloring in it yet. And that's just the result of the molecules being slower. They are, they're cold, they're huddling together for warmth, so they're not moving around very much. But in this hot water, there's lots of energy, and that means lots of molecular motion, which makes the food coloring spread out more. And that's it for today. I don't know what's going to happen tomorrow. We'll see. I know that we will all be home and that I will have something for you. So have a great day. And I'll see you next time.